Greetings! In the previous video, we've looked at the basics of geometry nodes. If you've missed that and want to know the fundamental concepts, go and watch that video. In this one, we will start building the donut. So, let's not waste any time and get to it. Okay, in the geometry nodes tab, we're gonna use the cube, so go ahead and add the geometry nodes modifier. We're gonna create a new node tree. I'll call this donut. We can use any object as a basis because we're not going to use the input mesh. So I'm going to delete this. We are going to create our own. Now, geometrically, a donut is a torus. But if you try to search here for a torus, we don't find anything. And even if you go to mesh here, primitives, we don't have a torus. We have a cone, cube, cylinder, but nothing that resembles a donut. So what we can do is bring a curved circle. Importantly, not a mesh circle, a curved circle. Because now we can use a curve to mesh node, and this wants a curve as an input. So we'll plug this here. What this is doing is, well, what it says, it takes this curve and makes it into a mesh. But now here we have a profile curve option. So if I duplicate this circle with Shift D and plug this into the profile, we start to see a donut shape. If we drop the radius of the second circle, there we are. We have a torus mesh. What's happening here, this node takes two curves and kind of sweeps the profile curve along the base curve. As an example, we can go to curve, primitives, and we can add, instead of the circle, we can add a spiral. Now if I plug this into the base, you see the same sweeping action of the profile circle, but this time along this spiral curve. This is a great way to create geometry, and we'll be using it a lot, so you should get accustomed to this. Now here we are changing the radius of the profile curve, and it has the effect of changing the thickness of our donut. But if I go too high, this starts to break down. So a great way to restrict any values while we are working here is to use a mix node. A mix node has two values, A and B, and this factor mixes between these two values. For example, if this is 0, and this is 2, at 0.5, this result will be 1, because 1 is halfway between 0 and 2. So what we can do here to the radius, this is a bit thin for a donut, so from around 0.3, like that, to around 0.6. So here in the mix node, the lower bound is going to be 0.3, and the upper bound is going to be 0.6. Now plug this in here and we have a much nicer control without values going crazy and breaking the geometry. Now here's something very cool. If you click and drag from this into empty space, it will open a search box where we can search for a node to quickly get linked to this input. So let's say if I type value, this will create a value node that will get linked to the factor, and we can control it from here. But what I want from this is if I type input, it will create a group input node. The group input, if you remember, was the one that contained the original geometry. But now, because we have the factor connected to the input, you'll notice in the modifier, we have the same slider, and we can control it from here. Now press N. This will open the side panel, or you can click on this little arrow thing. In the group tab here, you notice these options under interface. These here are our inputs and outputs. If the dot is on the left, it's an input. If it's on the right, it's an output. Here you can see we have the geometry output, the final outcome that we see here. This geometry input is our original cube mesh, And here's the factor that we've just created. Underneath are all the settings for any particular input. So the type of this is float, a number. There's also a option for subtype. Right now, that's a factor, which means we have this blue slider thingy. If this was none, we won't have this. There's also an option for percentage. So we have this as a percent. Angle, which will show degrees, and some others. And they're all slightly different. We can set a default value. So let's say the default now, it's 0.5. To bring it back to the default, we can hover over here and press backspace. This will bring it to whatever value we've set as a default. We can also set a minimum and a maximum values for the slider, which will limit its control. So from 0 to 1. We could have used these values, 0.3 and 0.6, and get rid of the mix node. It works the same, but now we have these arbitrary numbers here, so I prefer having the mix node and leaving this from 0 to 1, because we can set the limits from here, and I can see this in context of the node tree. But also we can plug stuff in here and set these dynamically, where we can't do this from here. This is much more versatile. Lastly, this being named factor, we don't know what it is, so we can rename inputs by double-clicking on it. I'll call this thickness. That's how we create custom controls for our modifier. Okay, now our next job here is to create some distortion to that donut shape, because right now this is a perfect torus, which is not realistic, obviously. A real donut would have some bumps and blisters, but before we make those, I want to address the resolution of the mesh. If we go to overlays here, we can check on the wireframe and see what we are working with. So we want to establish some base resolution for the mesh. It will be like when you're modeling manually, you create a mesh with some base resolution and then subdivide it if you want to add further detail. So right now it looks a bit sparse. We can change this by coming back to our circles here. We have a setting for resolution. If we change it on the main curve, it will have an effect along the donut. If we change it on the profile, it will be across the donut. As a general rule, we want twice as many segments on the base than on the profile. So if this is 60, this will be 30. It creates even looking faces, and it's an easy ratio to remember. Now we can set this manually, but a more clever way is to make this automatic. For that we can use the humble math node. This is like the workhorse of geometry nodes. We use it all the time. In this dropdown, we have a ton of math functions to choose from, but what we want is divide. Next, I'll add an integer, 60, okay, and plug this in here. But for the profile, I'll divide this by 2, like this, and plug it in here. So now, whatever I set here, in here it will be half that. So that's much easier. I think about 100 for now, it's dense enough. This math node is a bit big now, so what we can do, if I press H, it will collapse it to this neat little thing that I'll place underneath this one. Furthermore, if I select these two and press Ctrl J, it will frame this in this frame node. Now I can move this as one whole thing, and if I move this individually, the frame will update around them. Then with this selected, I can press F2 to rename it, so I'll call this resolution. By default, it is this black color, but I'd like to change it to a more appealing one, so go to the N panel again. We can go to the Node tab, and here we have an option for color. Check this and pick some color. I like something like dark blue, like this. While we are here, I'd like to give the input nodes a distinct color, something like this yellow. And this will help us later on when we add a lot of these. It will be much easier to find any control, because with this gray color, it kind of blends with the rest of the nodes. So, yellow, like this. And let's also frame these. I'll call it donut thickness. Also, if I select this, then this, while holding shift, I'll select both with this active. We can go next to the color here, copy color. And this will copy the color of the active node to the rest in the selection. It's very important to stay organized like this, because as this thing grows, it will be very easy to get lost in your own node tree. So this is a very good practice. So how can we deform this donut? To deform something, we're going to use a set position. This node gets all the points of our mesh and either sets their position individually one by one, remember this is a field, or offsets them from their current position with this vector here. Think of it as we are moving each point by some amount in a certain direction, which is what a vector is. And that vector is this thing right here, okay? Let's get rid of the wireframe. By the way, if you are using some option over and over again, what you can do is right-click on it and select Add to Quick Favorites. And now over here, if I press Q, we have the wireframe checkbox in this menu. Much faster. Okay, back to the deform. We want to offset the points sort of perpendicular to the surface of the donut, like this. Now, this perpendicular is called a normal. It's normal to the face orientation. So drag from here and type normal. There. Now, the normal vector is perpendicular to the surface and it has a length of 1, which in this case is a bit too much. So what we can do is scale this vector down. So go ahead and search for vector math, which is like the math node, but for vectors. And we won't go into all of these. What we want is the scale function. Then drop this in between. And now we can scale the offset down. By the way, if I select the set position, I can press M and it will mute the node and make it have no effect. Now it reads this path and you can see the noodle underneath by passing this node. This is a very fast way to see what effect any node has, just by pressing M. Now that's fine, but right now we are just inflating the donut uniformly. We want variation in this to create all the bumps. So naturally, for that, we're gonna bring a noise texture. So in Blender 4, we have some changes to the noise texture. Now we have this normalize option. When this is normalized like this, the noise texture will output values between 0 and 1 in that range. But if it's not, it's gonna output values between -1 and 1, I think. Basically, it's gonna have negative values as well. And that's what we want, because here, let me preview this. Where it's negative, it will push the donut in. Where it's positive, it will push out. So the overall shape will stay balanced around this. It won't push too far in one way or the other. And also, the other change here, we have this lacunarity, the scale of the Perlin noise octave relative to that of the previous octave. What the hell am I reading? Basically, we have two layers of noise on top of each other, so you can have a very big pattern of noise with a very low scale, and then on top of it, a much finer noise that will create a richer texture. And this kinda controls the difference between the two levels. So increasing this will make a finer and finer sublevel. Anyway, let's reset this with backspace and connect it to the scale. Obviously, this is a bit strong, so what we need is to multiply this. You can just drag from the noise here and type multiply. It will create a math node with the multiply selected. And then set this to 0, then increase it slightly until it looks good. I'd say around 0.07. Also, I want the scale of the noise to be a bit low, around 1. And yeah, already you can see a much nicer donut. Maybe we can drop the roughness a bit, but yeah, much more organic shape. Here before, a perfect torus, after, actually starts to look like a real donut shape. Okay? I'll group this and call it donut bumps. Okay. Well, that was the easy part. Now we are gonna get into the weeds. Before we continue, I want to show you how we can create our own custom functions that we can easily reuse on other parts of the node tree. Thankfully, we have a very useful node for that. Let's say I want to create a gradient attribute for our object here, goes vertically from 0 to 1. What this would do is create a positional map of the points of our mesh. So the lowest ones will have a value of 0 and the highest ones will be 1. And this will be regardless of the shape or the size of the object, so that we can reuse it. So what we can do is get the position, okay? We can preview this. And this is how vectors look like in Blender, this rainbow looking thing. We don't have to worry why that is, because what we want is only the vertical component of the position vector, the z component. So what we can do is we can split this vector into its components with a separate xyz node. Plug the position in here, and what we want is the z. Here, that's 0. All these are negative, and these are positive. But what we want is for this range to be from 0 at the lowest parts and going up to 1. And that's what's called normalization. We want to normalize this range, bring it from 0 to 1. Okay, how can we do that? First of all, this is fine for previewing, but if we want to work with this, we need to determine that this is the geometry we want to sample, and not this one. For that, we're gonna use a sample index. So drag from here and search for sample index. This will read an attribute from whatever geometry is connected here. Float, yes. The z here is a float. And points, yes, the position of the points. So let's connect this in here. And right now we are reading this attribute of just the 0th point, which is apparently somewhere down here, because it's all black. But we don't want a particular point, we want to sample all points. So for that, in the index, we need to plug the index field. This means sample all the points. Okay, we are back to this. Now we want to make it 0 to 1. To remap any range, we're gonna use the map range node. This will take some range with its minimum and maximum and remap it to some other range set here. Here, let me draw this so it's clearer. That's the number line. We have some range somewhere on it, and we can remap it to some other range, which we can set from these two, minimum and maximum. The value input will take a value from the first range and output the remapped value from the second range, if we want a single value, but we want the entire range, so go ahead and plug this in here. Now we need to know the minimum and the maximum of our z position attribute here. For that, we have a very handy node called the attribute statistic. Here we can plug any attribute, make sure it is set to the appropriate data type and domain. We also need to plug the geometry we need to read from. And the node will go through the attribute and give us the mean, median, and what is it doing? It goes here through in this case, the z component of our position, and if it's the sum, it will just add all these numbers and give us the sum. But what we are interested in is the minimum and the maximum, so we can use them in the map range. And we make that range 0 to 1. That's how to normalize an attribute. So I'll take these two, and what we can do is group them by pressing Ctrl G. This will bring those nodes into a new group with its own inputs and outputs. And if you're wondering where the rest of the node tree has gone, over here you can see we are in geometry nodes, the Doughnut node tree, and then into this new one. To go back, we can press Tab, kind of like going into edit mode, and there's the new group node created. It takes the geometry, the attribute, and normalizes it. So let's call this normalized attribute. Also, I'll group all of this as well. Ctrl G, Tab to exit. I'll call this vertical gradient. Now we can just plug any geometry here and it will give us that gradient. Just it says input here. Let's tab back in and let's rename it Geo for geometry. Okay. So what we can use this for? Many things, one of which is I want to sort of pinch this donut in the middle, because that's what tends to happen to donuts when they are cooked. They form this seam in the middle. So we can take our gradient here and use it as a base to create a map of values, which will then use this map to deform the donut. Kind of like the way we use the noise texture for the deformation. Just instead of using this noise map, we will make our own. Generally, when we make maps, we want them to be normalized between 0 and 1, because it makes it easier to work with. We can always multiply it to change the influence, or remap it entirely with a map range. So for our center pinch, we want a band of values around this donut with the highest values in the center, and on the top and bottom we want zeros, because we don't want any effect here. So let's take this vertical gradient, and instead of going one way, from 0 to 1, we want it to be the highest in the middle, so 0 to 1 to 0, like this. The easiest way to achieve this is with another node, a float curve. Don't be scared from this, it's really useful. You see how our range goes from 0 to 1 now? So this midpoint here is 0.5. We can click here and change it to be 1. You see it created this curve here. We don't want that, so check on this right here to make it linear. Also bring the end back to 0. So we have 0 to 1 back to 0. And we can be more precise. See, it's not exactly in the middle. This is the position of the point, so set it to 0.5, and this is the value, set it to 1. So let's see what we've made. Let's bring our deformation setup, set position. In the offset, we add the normal, and then scale that normal. And our map goes into the scale. Okay, first of all, it's pushing it outwards, because this is positive 1. So let's multiply this by negative 1. But that's a bit too strong, so let's try negative 0.1. Yeah, that's more like it. That sort of range. Negative 0.1, 0.2. See, that's too strong. We want it to be around here. Now, if we look at the map, it's a bit too much influence on the top here. I want it to be more concentrated in the middle. So what we can do is just click here and drag this curve a bit down, like this. It will increase the dark region on the top here. It will make the groove a bit better looking. Okay, this is how deep it goes, so we can make a control out of this. Like before, add a mix node, and we want this to be from 0 to about negative 0.15, something like that. Then we can drag out an input for this, Let's call this center pinch. I'll give the input the yellow color. Lastly, here, instead of the multiply, we can drag a map range from this, okay? And we plug the mix into the max slot down here. And right now it works the same, but now in the map range, instead of a linear, we can use a smooth step. And this smooths it up a bit. With linear, it looks more like a burger, but with this, it's a bit more smooth, like a donut. Okay, now that we know how to use maps, we can speed things up a bit. It's looking alright as a base shape, but I want to add more detail so it looks more realistic. For that, we're gonna need more detail on our mesh. So I'll increase this drastically, somewhere around 800. We need a lot, okay? While we have this pinch, I find that on some donuts, a small crease forms in the middle, probably while cooking. We can add that. It's subtle, but it adds a nice effect to the donut that will increase the believability. Alright, I'll copy the center pinch setup, okay? We have the same map, but we need to really crush that to a thin line in the center. Now, you can fiddle around with the float curve here, but a better way to do it is, I'm gonna make some room here between the float curve and the map range. We can add a math node with a power function. This is a number raised to some power. This is the base, and this is the exponent. This will have an effect like, on 1, there's no change, but when I increase the exponent, the black part of our map will increase, and the white will get crushed into a smaller and smaller area. So, right about 10 here. Okay, let's see what we've done. It's a bit too strong. Let's remove the control and set it manually. Should be about negative 0.01. Something like this, subtle. Although it's a bit too straight, which is not realistic. We need to distort it up and down. The way we can do this is, first, I'm gonna right click on the vertical gradient group and I'm gonna ungroup it. Now what we can do to the position here, we're gonna add a noise texture. And we're gonna mix those two together. So bring a mix node, and this time we're gonna set it to color. Okay, now plug the position into the top socket. The color noise goes at the bottom. You can already see quite a lot of distortion here. What we're gonna do is set the blend mode not to mix, but to linear light. Don't ask me why, but that's very standard when we try to distort some positional coordinates. Okay, now lower this influence way down, around 0.05, and we'll increase the roughness to around 0.7. This looks alright. Okay, the last thing we need to add is more fine bumps. For that, the first thing we can do is here in the initial bumps, we can increase the lacunarity a bit. This has quite the effect, so I think around 3 looks kinda good. Also, to the end here, we will add another display setup. And instead of the noise texture, we can add a Voronoi texture, because it's gonna allow us to add this sort of blisters and fine bumps, but also little cracks that may have formed on the surface that I find on some donuts. For that, we can set the Voronoi texture to distance to edge. That's what this looks like. Okay, we're gonna copy the distortion setup here and add it to the Voronoi in this vector socket. To the noise here, I'll max out the roughness and I'm gonna add a little distortion here, like 0.1. The Voronoi, normalize it. I think I'll increase the scale a bit to about 6, the detail to about 3, and the lacunarity a bit up as well to 3. Okay. Then multiply this and add it to the scale. Okay, but it's a bit too washed out right now. We need more contrast to this. So let's power this as well. But this time let's set the exponent below 1 because we want to increase the white. So about 0.4. Now this is pushing outwards only because this texture is normalized, so it's O positive. But we want the cracks here to be negative, so they push into the donut. So let's map range this from 0 to 1, let's make it -1 to 1. And while we're here, set the map to smooth step. This will add a bit more contrast to the detail, okay? This should be quite small. I think we used 0.007 before, but the cracks are a bit too visible now. But that's okay because we can increase the roughness of the Voronoi and it will wash out most of the cracks. See? So 0.7, 0.8 looks alright. Feel free to tinker with these values. I find that this gives me the best results. Well, I'd say that's a finished donut model. You can expose some of these controls, like we did for these, but I don't want it to be too complicated because most of the visual appeal is gonna come from the glazing and the sprinkles. This here is just the base so that you can get familiar with the notes. In the next video, we'll start making the glazing. So, see you there.